So welcome to this latest video 162 Maths, and in this video we'll be going over a topic test related to types of numbers. Now as always I'll include a copy of the questions for you to have an attempt at, and all you need to do is just simply click on the link in the description, and I'll also go through all the types of numbers and explain to you what it is you need to revise for this topic. Now before we get started working through some past exam questions all related to recognising the types of numbers, let's just have a quick overview over what it is you need to revise and know. Now, in terms of the types of numbers you need to know, the first one is a pretty obvious one, which is your prime numbers. Now, ideally, you should know your prime numbers up to at least 50, but ideally, at higher GCSE, you should be knowing your prime numbers and be able to spot them all the way up from 1 to 100. And as you can see on the screen is a list of those prime numbers. So it's always important that you familiarise yourself, particularly with the tricky ones. There are certain tips that you know, like 2 is the only even prime number, and prime numbers will either end in apart from 5 and 7, so number 5, it will either end in a 1, a 3, or a 7, or a 9. So just be mindful of those, and they're easy to spot. There are common ones that people think are prime but actually not. For example, like 51, that's 21 times 17 times 3. So just be mindful of those types of ones that may look prime but actually aren't. The next one is looking at square numbers. Now square numbers you need to know up to 16 ideally, but if you're doing foundation, up to 12 should be absolutely fine. Now as well as knowing square numbers, you also need to be able to recognise the root of those square numbers. So recognising that the square of 13 is 169 should be able to tell you that the square root of 169 is therefore going to be 13. We then move on to cube numbers. So again, ideally, although cube numbers involves quite a lot of mental arithmetic in your head if you're trying to work it out, but a cube number is basically a number that's been multiplied by itself 3 times. So recognise that 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, 5 times 5 times 5 is 125, and also then recognising that 10 times 10 times 10 is 1000. Now as long as you're able to know how to calculate cube numbers, that should be absolutely fine. But where this comes into play is when you're asked to cube root a number, in which then it's quite difficult to recall. But typically speaking, if you're asked to cube root a number on a non-calculated paper, it's most likely going to be 125 or 64 or 27 or 8 or even 1000. So these are the most common ones that you're more likely asked to cube root. Anything beyond that will probably be on a calculated paper. Now moving on to triangle numbers. Now this one is slowly making a comeback. Now it's difficult to recall what is a triangle number, so what you need to be able to do is be able to know where those triangle numbers come from. Now if you've ever played pool or snooker, basically a triangle number is the number of balls you need to make a triangle. So one way of remembering it is recognising that you've got 1 there, the next one will be 3, then it will be 6, and then basically what you notice for every triangle that you draw, that the difference is increasing by 1. So the first difference is 2, then the next difference is 3, then the next difference is 4, the next one will be 5, the next one will be 6, next one will be 7, etc. So as long as you know how to generate those triangle numbers, you should be absolutely fine. The next type of numbers you also need to be able to know are factors, and a factor is a number that divides into without leaving no remainders, and a multiple, which is a number that appears in their multiplication times tables or column or row, depending on how you want to interpret it. But it is really important you know the difference between the two. So a factor is a number that goes into, a multiple is a number that generates multiples of it. So again, try and find connections to make your revision that little bit easier. So let's get straight into some questions. Now again, a little reminder, if you want an access to these questions, all you need to do is just simply click on the link in the description below and you'll have access to all of these questions. So looking at question 1, it says write down a square number between 40 and 70. So for this you've got a couple of choices. You could either have 49 or 64, so any of those two, but remember you just want to write down one number. So they'll be writing multiple numbers, any of those numbers would be absolutely fine. Moving on to 1b, it says write down a prime number between 30 and 40. So again, a couple of options you've got here. So either 31 or 37. For question 1c, it says write down a cube number that's greater than 20. So basically anything over 3 or 2 cubed, I would say. So you could have 27, which would be the first one. You could also have 64, you could have 1000, but just make sure that it is a cube number, or you could even have 125. So it then says write down all the triangle numbers less than 20. So again, recording that list, so we've got 1, 3, 6, 10 and 15. Then moving on to question 2.8, says write down all the factors of 18. So we want to write down all the numbers you can divide 18 by that leave no remainder. Now this question is a lot easier if you do the numbers in numerical order. So 1, 2, 3, and then you go 5 doesn't go, 4 doesn't go, 5 doesn't go, 6 does go, 7, 8, 9, and then 18. Another way of looking at it is basically 1 times 18, 2 times 9, 3 times 6. And you can see there that you would always then double check to make sure that you've got all the numbers. So there is my list of numbers. Moving on to 2b, it says how many factors does 16 have? So again, listing the numbers of the factors of 16. So we've got 1, 2, 4, 8 and 16. So the answer then is going to be 5. It then says what is the highest common factor of 12 and 18? So the highest common factor is basically the biggest number that goes into both 12 and 18. So if I write down all the factors of 18, so I've got 1, 2, 3, 6, 9, 18. And then for 12, I've got 1, 2, 3, 4, 6 and 12. I want the biggest number that appears in both those two lists, which is 6. Now, for these types of questions, with it being 2 marks, I definitely would show some working out. So even if you know the answer straight away, just make sure you are showing some working out if possible. But to be fair, where the 2 marks would come from is you get 2 marks if you just wrote 6, but you'd only get 1 mark if you wrote 1, 2 or 3. So if any of those numbers in green you wrote, you would have got 1 mark because it's still a common factor, it just isn't the highest one. Then moving on to question 3, it says write down 3 different multiples of 13. So basically write any 3 numbers in the 13 times table. And again, there are an infinite number of combinations you could have, but the most obvious ones will probably be 13, 26, 39, I would say, first 3. Just keep it simple. You could even go 130, 1,300, 13,000, anything along those lines. You can use your creativity, as long as it's correct, it's all good. Moving on to 3b, it says work out the lowest common multiple or the LCM of 12 and 30. So again, depending on how you want to work this out, if you know the answer straight away and it's correct, you'll get full marks. If you give a common multiple but it's not the lowest, you then would lose one. You'd only get 1 mark. So the multiples of 12. So again, what you want to do is always start with the biggest number if you're going to write down the times table. So I've got 30, 60, 90, and then I've got 12, 24. I'm just going to stop when I get a number that's on the bottom row. So I get 36, 48 and 60. So there is my lowest common multiple, which is 60. Moving on to question 4, it says explain how you can tell if a number is a prime number. So again, lots of different combinations you could have, but the actual definition of prime numbers that I personally prefer is if it has only 2 unique factors, would be my explanation for it. The next one, 5.8, says work out 23 squared. So all you need to do here is just work out 23 times 23. Now again, it's entirely up to you how you want to do it. You can either do it the column method, you can do the grid method, and it's entirely up to you, whatever you feel more comfortable with. There's no right or wrong way, or the only wrong way is if you get the wrong answer, but the correct answer you should have is 529. Then working out for 5b says work out 7 cubed. Well, 7 cubed is 7 squared times 7, and so that's 49 times 7. So if I then work out 49 times 7, again using any preferred method, we should get an answer of 343 rather. Moving on to question 5c, it says work out 2 to the power of 5 times 3 squared. Well, 2 to the power of 5, and again I will do these using your fingers, so 2, 4, 8, 16, 32. and 3 squared is 9, so I'm going to do 32 times 9, which is 288. And again, non-calculated, just do it any which way as long as you get the right answer. Moving on to 5D, it says work out the cube root of 64. Well, which number cubed gives you 64? Well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed 64. So the cube root of 64 is 4. And what number squared gives you 144? Well, that's going to be 12. So it's going to be 4 plus 12, which is 16. Then moving on to question 6, it says show that 152 can be written as a sum of a power of 5 and a cube number. Now I'm going to assume that this is on a non-calculated question. So what we need to do here is, first of all, we need to write down powers of 5. So powers of 5. Well, 5 to the power of 1 is just 5. 5 squared is 25. And the next one is 125. Now it's definitely not going to be 5 to the power of 4 because that's a lot bigger than 152. So then if I then do 152 take away 5, well, that's going to give me 147, which is not cube. Then if I do 152 take away 25, that's going to give me an answer of 127, and that's not cube. So that if I then do 152 take away 125, that gives me an answer of 27, and that is cube. So then I've got 27 plus 125, which is 3 cubed plus 5 cubed. And there's my answer there. Now in terms of the mark scheme, they probably would accept for 2 marks that answer, but ideally if you can, write your answer as a cube number and as a power of 5. Then moving on to question 7, it says that A and B are both different prime numbers. They are each less than 20. Give an example of where A plus B is a square number. Well, if I write down all the prime numbers that are less than 20, so I've got 2, 3, 5, 7, 11, 13, 17 and 19. So on a connection of those, now there's again a couple of answers you could have. You can have 2 and 7. You can have 5 and 11. You can have 3 and 13. You can have 17 and 19. So any of those will be fine because these two added together give you 9. These two added together give you 16. These two added together give you 16. These two added together give you 36. So any of those combinations would be fine for the full 2 marks. Then moving on to question 8, it says that x is a prime number, y is an odd number, p equals x squared plus y squared. Circle the correct statement about p. Well, if x is a prime number, then a prime number squared is either going to be odd or even, because if it's 2, which is the only even prime number, 2 squared is 4, so that's an even number. But any prime number, other prime number, which is odd, an odd number times an odd number is always going to give you an odd answer. Then if I look at an odd number squared, well, as I've mentioned, odd number squared is always going to be odd. So then either p is either going to be a odd plus an odd, which is an even number, or p could equal an even number plus an odd, which equals odd. So it can't always be even, can't always be odd, but the correct answer is that it could be odd or even. Now the reason why it can't be prime is because a square number is not a prime number. Apart from 1. So there we go. But 1's not prime. Then moving on to question 9, it says that A is a common factor of 36 and 54. B is a common multiple of 2 and 3. Work out the highest possible value of A over B. Now, in order for us to get the highest possible fraction, then A needs to be big and B needs to be as small as possible. So if I work out the common factors of 36 and 54, well, again, if we look at 54, common factors are going to be 1, 2, 3, 6. Oh, I'm writing 3 again. 6. We've got 9, 18, 27, and 54. And for 36, we've got 1, 2, 3, 4, 6, 9, 12, 18, and 36. So the biggest number that appears in both these lists is 18. So the biggest number A can be is 18. The smallest common multiple of 2 and 3 is going to be 6. So B equals 6. So then it's going to be 18 divided by 6, which gives me an answer of 3. Then moving on to question 10, which is our last question. It says that Sally is trying to remember a 3-digit code. She knows the rule that the first digit is a square number, the second digit is an odd number, third digit is a multiple of 3. How many different codes are there to follow this rule? So in terms of the first digit, so the possible ones, we know it's a square number, but we also know it's got to be a single digit. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so they're the only options we've got. For the second digit, we know it's an odd number, so that could be 1, 3, 5, 7, or 9. And then the third digit is a multiple of 3, so 3, 6, and 9. So in terms of the total number of possible numbers, we've got 3 for the first digit, 5 for the second digit, and 3 for the third digit. So to find the total number of combinations, I just multiply all of those 3 numbers together, in which I get an answer of 45. And that concludes this types of number test.